This video gives an overview of CNA with blood, so we'll be reviewing the aspects of that plate and also screening for antibiotic resistance or sensitivity. Remember that CNA stands for colistin nalidixic acid. That is a selective ingredient that prevents gram-negative organisms from growing. So anytime you see any growth on these CNA plates, the organism is gram-positive. We also have blood included as a differential material, and we're looking for varying degrees of hemolysis reaction. So I'll talk about those as we go through the results. Most of this should be reviewed from CNA blood that we covered earlier in the semester when we first introduced selective and differential media. If the organism is able to completely hemolyze the blood, meaning that it completely break it down, you'll have a complete clearing. And in that case, you'll actually really, I tell folks you can really pretty much read newsprint through it in most cases, even if there's a tint there, because the blood has been completely broken down. So this on the right here is beta hemolysis. You really, you can see right through it. Don't focus so much on, that it's completely clear. Sometimes you see that. Sometimes you see a slight yellowish tint, but you can see here, I can see directly through the back, and that's beta hemolysis. Now also I'm looking at the same time here for antibiotic sensitivity, and in this case we used an A disc or the bacitrine disc, and the bacitrine disc will have a dime size clearing if the organism is sensitive to that particular antibiotic. Now, the antibiotic discs, again, you want to always look at what the zone is of sensitivity. It varies for different discs, so you always need to check that. And I mentioned that when we talked about novobicin back in the Staphylococcus species screenings. Over here on the left, we see what we call gamma hemolysis, and you always want to make sure you're looking through the bottom of these plates to read the hemolytic reactions. Gamma hemolysis means there's no hemolysis. You can see here the blood shows no change. There is growth on the plate, which might, again, make a little whitish cast, and you can see that on the top of the plate a bit here. But there's actually no change here. The disc here, you can see the organism is completely resistant because it can grow completely up to the top of the disc. And that means that this particular organism is resistant to bacitracin. So you always want to compare that zone of clearing. Now looking at other antibiotic discs and also a different type of reaction, now we're going to look at a partial hemolysis, or what we call an alpha hemolysis. This is different than beta because there's a partial blood digestion. Blood isn't completely broken down, and we see a greenish cast. Now again, I'm going to kind of compare this by putting this up to our newsprint. Really can't see through it here, but we certainly can see that the blood has changed and it's partially broken down. Again, a key to look through the bottom on alpha hemolysis, otherwise you may get off track on the type of hemolysis that's occurring. So let's compare our alpha and beta together here. So here's my beta next to my alpha. So you should see quite a difference here. And I'm holding it up here a few inches from a light background to really see the difference. So again, with the clearing, I can see all the way through here on my left. On the right-hand side, I might be able to see that there's something behind there, but I certainly can't clearly see through and read through it. This is the alpha hemolysis plate. So both reactions seen on this plate are alpha hemolysis. What we do see is a difference in the optokin antibiotic disc result, or what we call the P disc. Again, we're looking for a clearing zone if the organism is sensitive. So here on the right, we have, again, at least a dime-sized clearing, somewhere around 10 millimeters in diameter, that indicates the organism is sensitive to this antibiotic, so it can't grow up all the way to the disc because it's sensitive to it and it's prevented from growing. This organism here on the left, however, is resistant to the P disc and can grow all the way up. The P disc, you're going to find, if you look at the key in your book, is going to be really helpful for distinguishing alpha hemolyzers from each other. There's only a couple of organisms that fall into the alpha hemolysis category, and so the P disc is going to really help you to start to break those apart. So again, just a quick recap on blood plates. You always want to make sure that you are looking from the bottom. I recommend holding it up to a light background. Make sure you can distinguish beta versus gamma, and versus alpha, which is that partial hemolysis. So be able to relate that to the degree in which blood is digested, or if it's not digested at all in the case of gamma hemolysis. And again, you remember on antibiotic discs, make sure you're aware of the correct size of the zone of clearing in order to indicate that the organism is sensitive versus resistant to a particular antibiotic disc. Also, you want to review on the CNA blood plate the selective and differential aspects. Again, the selective is the colistin nalidixic acid that selects for gram-positive organisms and selects against gram-negative organisms, and also the differential material, which in this case is the blood. And that is an overview of the CNA blood plate with antibiotic disc sensitivity.